Hello guys, welcome to Houdini Made Simple. In this two-part tutorial, we'll be creating step-by-step a 3-layer chocolate effect in Houdini using FLIP. In this first part, we'll focus on creating emitters, setting up the FLIP simulation, adjusting the viscosity, and solving stepping issues. So guys, let's do first a quick overview of the setup. First, I have a backdrop, pretty simple, and then I set up 3 cameras. One is going to be a wide shot. Then we have 2 close-up, one on the left side and another on the right side, just a bit closer. And then we have the ice cream. I'm gonna leave this alembic on the video description so you can get it. And simply I just use a few transforms to first scale down, apply some rotation, and then another transform just to put this in the center of the shot. And then I created a collision source just to set up the collision geometry for the seam. On the left side we have the geometry, on the right side we have the SDF that I went a bit lower with the voxel size, so we have a nice resolution. So for the emitters, we're gonna create a geometry node. We're gonna rename this, let's type something like flip chocolate. And then inside, we're gonna create a box. Now I'm gonna be resizing this box. The value that worked for me were 0.02, 0.1, and 0.0 and 0.25. Now I'm gonna rotate this 90 degrees because then I'm gonna be moving this on top of the ice cream. I'm gonna create a transform node and connect this to the box. Display the transform, and now we can just move this on top of the ice cream. So you can move this box on top of the ice cream as you need to. In this case, I'm just gonna use the values that work for my project. Next thing I'm gonna do is to create some rotation using a sine wave. I'm gonna copy and paste the expression. So with this expression, we are creating a sine wave based on the frame number. So the sine wave is going to go up and down. We have 0 in the center, and then we have 1 on the top and -1 on the bottom. If we multiply the frame by 20, like in this case, we're just going to get a higher frequency, meaning that the sine wave is going to go up and down faster, something like this. And with the fit expression, we are taking these values, that's going to be from 1 to -1, and we are just mapping those to -10 to 10 so we can have more rotation on this axis. So if you left click on rotate, you can see now how the value is changing from -10 to 10 as we move through the timeline. Now I'm gonna create a second transform just to move this box forward and backward. I'm gonna rename this to rotate and the second one to translate. And before applying the sine wave to the transform, we're gonna move the pivot to the center. Just click on move pivot to centroid, and this is gonna move the pivot to the center of the object. Now I'm gonna go ahead and copy and paste the sine wave expression on the Z axis. And this sine wave is basically doing the same as the one before. In this case, just to move again back and forth the box in the Z axis. And in this case, I just want to move just a little bit. That's why we're using values of 0.025. So if we check the box, you can see that it's rotating back and forth and also moving forward and backward, and it's gonna give us a nice flow when we create the emitter. So once we have the emitter ready, I want to create 3 of them. So I'm gonna create a null node just to organize things, type emit 01, and then holding the Alt key, we can duplicate to create the other 2. And finally, I can create 2 transform nodes just to offset a little bit the second and the third emitter. So I'm gonna use the first one as reference, and in the Z axis we can type 0.05 just to offset and move a little bit, and then we can do the same on the third emitter. In this case, we're gonna type 0.1. Then we can create a merge node to see all together, and if we display the merge node, we have all the 3 emitters rotating and moving forward and backward. So these are the boxes we're gonna be using to emit, but before actually creating the emitter, we're gonna go and create a dot network, and inside this dot net, we're gonna set up the flip simulation. So if we double click, we can create first the flip object, and then we need a flip solver. Now we can connect the object to the solver. The solver is gonna be processing all the information, and we can create already a gravity that we know we're gonna be using for sure. Then we can set up the collider. So let's create static object. And the way I like to set this up is on the sub path, we're gonna choose the geometry we previously created. On the ice cream, we can select the collision geometry. Then under collisions, we need to switch detection to volume collisions. Make sure on mode we have volume sample, and we're gonna be sampling the collision SDF we also create using the collision source node. So we can go and where is this? There you go, collision SDF. Once that's ready, we can create a merge node, connect this into the tree, and connect the static object. We're gonna shift R to switch the order. Next, I'm gonna configure properly the flip object. As you can see now on the viewport, the bound is pretty huge for the ice cream size. So we can go into the volume motion tab and change the size. And you can adjust this just typing some values on settings, or if you want, you can also use the arrows on the viewport, the red arrows, just to make this smaller. In this case, I'm gonna be typing some values that work for me before. And now we can see in the viewport that the bound has a proper size for this simulation, so we have enough room on top for the emitter we're gonna be adding later. And if you see that blue weird box, we can go into a flip object and delete this from the subpath. And since we're here, we wanna change the particles to particles instead of spheres. And now we are ready to go one level up, and let's create the flip top source. We're gonna be using these nodes just to create the emitter. We can go inside the flip object, copy the particle separation parameter, and on the flip source, we can paste here on particle separation. So this is linked, and same with the voxel size. And if we scroll down, another thing I want to change on the oversampling, I'm gonna enable and change this value to 15. I also want to create some initial velocity on the particles. They're gonna be falling because of the gravity, but I also want to have some initial velocity. So I'm gonna create a point velocity node just after the flip source, and let's change this to set value, and on add velocity, let's type -1. So we have downward velocity, and we're not seeing anything yet. We only have 1 point, so this means that maybe we don't have enough resolution on the emitter because we are working in a small scale simulation. So let's go inside the dot network, and on the particle separation, let's try a lower value, something like 0.008 maybe could work. And now if we go back one level, we can see that the SDF is displaying on the viewport. We also have points, and if we display the velocity, we can see the downward velocity is working. Now we can go back to the .NET, and we can actually create a volume source to start emitting using the emitter we just create. We can go ahead and create a merge node, since we know we're going to be using a bunch of emitters. Connect this to the last input from the flip solver. So on the volume source, we need to switch a few things. So we can go on subpath and type /emit 01 to reference the emitter. On the preset, we can choose source flip, and right away we should see some particles on the viewport. So if we hit play, we can see in the viewport that everything is working, but it's not looking as chocolate. It's looking more like water, and that's because we didn't enable the viscosity attribute yet. So let's go ahead and do that. So in order to enable the viscosity in a flip simulation, we need to do a few things. First, we need to go into a flip object, and on the initial data tab, we can add viscosity, we can enable a viscosity attribute. Then on the flip solver, under the volume motion tab in the viscosity tab, we can also enable viscosity and then make sure that we are using viscosity by attribute. Now back to the emitter, we need to create a viscosity attribute. So let's create an attribute create node. Connect this after the point velocity, and under the name box we can change this to viscosity, and if we scroll down we can change the default value. We can leave type as float, and on the value let's try this value like 250. And if we go to the geometry spreadsheet, now we can see that we have this viscosity attribute of 250. And then if we go back to the .NET, we can hit play again, and now this should be working. As you can see, when the fluid is colliding with the ice cream, now it's looking way more thicker and slower, more like a chocolate you would expect to react. And if we take a quick look at the emitter, we can see that it's not super smooth. We can see some kind of like stepping. And although we can add some sub steps into the simulation, we also need to do some fix on the emitter itself. So we're going to be adding some sub steps to the simulation, but we need to make sure that we also have some step information on the emitter. So if we check, if we go to the global animation options and we disable integer frame value, so we can actually see the fraction between frames, you can see as we move through the timeline that the box is not moving in between frames, just moving from 2 to 3, 3 to 4, but not within the fraction. In this scenario, we have two ways to fix this. One is using a different expression. In the expression, we are creating the sine wave based on the frame, and the $f is going to be integer, so we can switch this into $ff, and this is going to be using a float frame. Same with the translation, we can switch that, and this is going to fix it. So now if we move through the timeline, you can see it's way smoother and it's moving through every part of the fraction. But if you are using, let's say, a geometry that someone animates for you, maybe it's an alembic, we can use a time blend just to create this information in between frames. So you can use any of these techniques just to add some fractional information on the emitter, so when we add sub steps into the sim, we have a smooth emission. So back to the flip solver, I adjusted the min and max sub steps to 2 and 4, and now we're going to have a way smoother simulation. As you can see, we don't have that clear stepping that we used to have. We still have some stepping, so we can really force those sub steps going into the .NET and taking these two sub steps in the .network. And now this is looking really smooth. So now I'm happy how this is shaping. And if we go to the main camera, we can hit play and we can see how the first layer of chocolate is falling nicely and smoothly on top of the ice cream. So I'm gonna move forward with the rest of the emitters. So I'm gonna speed this up because it's basically just duplicating what we just did on the first emitter. So we're gonna select the flip source, point velocity, and the viscosity attribute, and with the dragging and holding the Alt key, we can duplicate and create the second layer and the third layer of chocolate. And if we go back to the network, we can duplicate the volume source to create the second layer, and same for the third layer. So finally, let's quickly set up a DOP import field. We're gonna import the .NET and copy paste and bring the flip object. On presets, let's choose a fluid, and we're gonna also create a fluid compress. Connect this into the DOP import field, and let's copy and paste the particle separation into the fluid compress, so we make sure we have the same value. And I'm gonna disable the call bandwidth, and right away I'm gonna create the file cache. let's rename this, and also I'm gonna be changing some settings that's gonna be my preference, but feel free to use everything as default. And on the advanced tab, let's initialize simulation ops, and we can hit cache. So the cache is ready, so we're gonna unpack the geometry so we can see the points. Connect this into the cache, unpack, and now if we hit play, we can see the 3 layers of chocolate falling into the ice cream. We do have some problems. We are working still in low resolution, but we have some points being created in between the emitters. This is not something we want. We're gonna be troubleshooting that soon. But first, let's split the 3 layers. We wanna create a blast node and connect this into the unpack node. And in the group option, let's select stream 1. Click on delete non-selected so we can keep that group, and we're gonna do the same with the second and the third. I'm gonna be meshing each one by itself, so that's why I'm splitting the layers, and we can merge everything just to display everything together, and we can use some color to each layer. So let's create one for each. So guys, so far everything is looking good. This is a great starting point. And on the second part of this video series, we're gonna be fixing, troubleshooting, and understanding why this problem between the emitters is happening. We're also gonna be working on the meshing process and troubleshooting the most common problems on these kind of close-up shots. So thank you guys for watching. I hope you enjoy, and make sure to check out the second part of this video series. Thank you, and I will see you on the next one.